Hello, everybody. Thank you for coming. My name is Ignacio Fuentes-Villegas, and I come from Spain, from Madrid. I work for BBVA, and I am the leader of the cryptography team. This is the agenda. First, I'm going to speak or introduce who is BBVA and what we do in cryptography team in the holding area. Secondly, I'm going to explain the different Vault installations that we have in BBVA, because we started many years ago with the open source Vault installation, and I'm going to explain how we had to expand our Vault installation when critical applications came and needed to constantly use of Vault, reading and writing secrets. And I'm going to explain what a hybrid architecture means for us in BBVA. I'm going to end my presentation explaining a very simple use case about the main mobile banking application of BBVA using Vault constantly, not just for storing passwords for authentication, but just executing critical transactions and using Vault constantly with a very, very high availability. And I'm going to speak a little bit about the future of using HSMs, KMS, encryption, and other things. So, who we are in BBVA? BBVA is a large group of banks with presence in more than 25 countries, with 6,000 branches, more than 100,000 employees, and more than 80 million customers around the world. We are the first bank in Mexico, we are the third bank in Spain, and we are also leader in many countries in South America and also in Turkey. I'm not going to explain the numbers, because I'm going to go into detail about some charts about the real installation that we have in Vault for the open source version and the enterprise version. BBVA is very good in digital services and innovation within the banking industry. In fact, we have the best mobile banking application in Europe for 5 years in a row. Because of that, our environment is very demanding in terms of availability and performance also. This is the environment where we are using Vault for all the applications around the globe, for all the banks of BBVA. And what we do in cryptography in general, this is a very basic example. But we're using keys and certificates, of course, as many other companies, to identify, authorize, or keep our communication secure. We are using cryptography in many use cases: ATMs, payment cards, point of sales, the mobile banking application, even in smartwatches, and internally for devices of the employees, servers, branches, and connections with all the providers we have. Even that cryptography is very important because we are implementing zero trust inside BBVA, so that we are using mutual TLS for all the connections inside it. And in particularly in the holding department where I am, because I am leading a team in Mexico and Spain, which is global, we are deploying the main components of cryptography to all the countries, which is part of the security architecture area. What we do is focus in 3 different things. We could divide our work in 3 main different topics. The first one is data encryption and data masking, covering encryption, obfuscation, and tokenization. The second topic is certificates, issuing certificates for identities, servers or even devices, thousands of certificates, external and internal. And the third topic is secrets. We provide tools to applications so that they can read and write the secrets they need. This is where Vault is used. Of course, in BBVA, so large a bank, we have many departments. Even my colleagues in security architecture, they are using Terraform, Nomad, Vault open source for the microservices installations. But what I'm going to talk in this presentation is about the core banking services that are executing transactions per thousands. Let me explain that we have two big installations of Vault in BBVA, which are deployed globally. The first one was installed many years ago. It is based in the open source version, and its main users are Jenkins and Ansible. The second installation is based in the Enterprise Vault installation. We call it Vault Runtime because it's used by runtime applications. And its main users are the mobile application, the desktop application, batches application are executing batches with millions of transactions per second, and even other type of applications, that data scientist applications, or any application in BBVA that is running critical transactions can be integrated with the Vault Enterprise solution. Before explaining how we have our Vault installed, open source and enterprise, I would like to say that in BBVA, we are always trying to compute hybridly. What does it mean for us to compute hybrid in BBVA? Is that we are executing our applications in both sides, in our on-prem data center and into the cloud, so that we are able to, for example, execute 50% of the traffic with Amazon Web Services and 50% in on-prem data center, having the same applications running at the same time. So because of that, our network department built this kind of network architecture. We have 4 regions. The first region is based in Spain, the on-prem data center. The second region is in Ireland, in Amazon. The third region is based in Mexico. And the fourth region is based in Amazon, Virginia. Of course, we are using other type of clouds like Google or Azure, but Amazon Web Services is the cloud that is being used more for the core banking services. Each region is connected. We have several rings, work network, live network, and central zone, so that we are able to just have visibility from each cluster. In fact, in each region, we have a very big installation of Vault Enterprise. Spain and Ireland are synchronized, as I'm going to explain later, with the chart of Vault Runtime. And Mexico and Virginia is also synchronized. We didn't decide to just have one big cluster of 4 regions connected because we wanted some kind of isolation between Europe and America, because we didn't want the data to cross between geographies. And also in terms of support, for example, the supporting team for this kind of installations are based in Spain and Mexico. They don't have the same change management procedures. The time is different. So we decided just to have 2 big Vault installations, one for America and one for Europe. But they are all the same, as I'm going to explain. In this picture, I am explaining how we have the first Vault installation in BBVA, which was installed many years ago, one of the first Vault real installation in production in Spain. You can see that we only have one cluster in the on-prem data center, which is consisting of 3 nodes with the Consul storage backend. And we only have one cluster in Amazon. What we are doing is just upload our backups to the cloud so that we are able to switch on the backup recovery system if the main data center goes down. Why are we doing this? Because we don't have the availability, the possibility of synchronizing data, because we have the open source version. This installation is only intended for building the infrastructure. Because of that, we call it Vault Infra. Because when you're deploying machines or you're deploying products, you need the secret in that moment. And then afterwards, once the secret is pushed to the machine, you don't need it anymore. So it's a very basic installation. We don't need any more right now. And as I explained in the picture, we are using Ansible and Jenkins, just regular utilities, not very complicated, to deploy our virtual machines in this core banking services environment. We are using DNS load balancing, or detection of the traffic, so that even when we have to redirect all the requests to the cloud, we have to manually change the DNS entry so that we redirect everything to the cloud. And we are using F5 devices for load balancing. This installation is enough for deploying the infrastructure, but it's not enough when you have a critical application that needs a very good availability and performance, as I'm going to explain later that we have in the next slides. So just make a quick recap. The first Vault installation is the open source version is only for building new machines. We don't have the possibility of synchronization of data because we have the open source version. And the performance also is not enough. In our tests, we got only 500 transactions per second. With that kind of performance, you are always worried about new projects coming to that Vault installation if they are using Vault every time. And if, of course, if you need zero downtime, it's very frustrating. And we wanted also a kind of isolation between the underlay infrastructure, which is only needed for deploying new machines or new products, or just executing operations like restarting machines or doing anything with the machines, some kind of isolation between the overlay applications, so that we are able that even if the tools needed to deploy the infrastructure are down, or above applications are still running because machines are running without any problem. So it wasn't enough for us, so we have to expand the solution and then install this kind of installation. This installation is designed or validated by HashiCorp with the help of the customer success support. We implemented this project last year, and in several months, we got it in production in Europe and America at the same time, more or less. We have 4 clusters in Europe and 4 clusters in America. This is depicting what we have in Europe, but we have the same structure in America. This is one of the best advantages we have, that we were able in BBVA to just have the same everything, network, machines, operating systems, versions, everything is the same between America and Europe, which is pretty easy for us, because if not, it would be very, very difficult to deploy architecture. And it's one of the clusters. We have 2 main clusters with 5 nodes using the integrated storage backend. We are using F5 load balancers so that we are able to redirect the traffic to the 5 nodes, not with the open source version, because you only have 1 main node and you cannot redirect to the other clusters that are just sleeping. And with that solution, we are using the 5 nodes fully. And we have the same in Amazon. We also have disaster recovery, cross-disaster recovery, so that we maintain capacity of the transactions per second we have, even in the main data center or the cloud are down. We are synchronizing and replicating everything so that when an application is writing a secret, immediately goes to the cloud. We are using geographic distribution of traffic with the DNS solution so that we are able to just detect where the requests are coming. And if the request is coming from the cloud, it goes to the cluster in the cloud. And it happens the same in the data center. We even have the same DNS name server for the 2 clusters, which is pretty convenient if you have to configure client applications. Other type of solutions that don't have this possibility, you have 2 endpoints for implementing that. So you have to implement on the client side the 2 different endpoints and then redirect the traffic by yourself. But with this DNS functionality, we have the same name for everybody. why we are doing this? Because in the hybrid architecture of BBVA, what we are trying always is just to avoid crossing traffic between our on-prem data center and into the cloud. Why? Because we have a limited bandwidth. It's not unlimited. Everybody is crossing traffic for loading, I don't know, backups or trying to connect up databases. But when you have the possibility in this architecture, you avoid crossing traffic because of that. And it's a simpler installation for us, because if you have all the components in all the layers crossing traffic, it's going to be very complicated. You have to be sure that the cloud environment is working properly. You have a real backup or just an alternative to your on-prem data center. Its main users are the core applications of BBVA, the front-end application and the back-end applications, as I'm going to explain later in the use case. Another recap. We have the enterprise version used for critical application, and it's already deployed in Europe and America and working in production for all the countries with an active configuration. And what is important for us is that in our test, we got per cluster 10,000 transactions per second, which is more than enough for running applications right now. And if we need more, we could add other clusters so that we are improving in this kind of performance. And lastly, but not least, automatic failover. In case the data center or the cloud goes down, we have the servers restored in 0 to 10 seconds, and automatically. Let me explain how we installed this Vault runtime installation in BBVA. The advantages that we have in BBVA is that, or advantage, it depends, because we are not using native services in the cloud for these core banking services. Because of BBVA so big, we are using anything from any provider. But it's this kind of installation, very simple for us, but with a very large number of machines. We even have in the front applications like 300 machines, and in the backend application like 100. In this kind of installation, we have the same in the data center or in the cloud. We have Red Hat operating system is the same. So we are avoiding any potential change in between the data center and in the cloud. And we also have the same in America, which is very important. So what we did is just to use Jenkins and Ansible just to execute with jobs the installation of everything. The creation of machines, installation of Vault, configuring alerts, logging, everything was or is performed with several jobs that are executed very easily, and you have all the cluster restored if you need it. For example, we do it so every 6 months, for example, if you need to reconstruct the operating system because you have to update the version of the operating system. And we are using Jenkins and Ansible for that. That was key to have the product in place in 2-3 months. What was the main problem we have in the installation was opening firewalls, of course. We don't have the firewalls opened automatically, so we have to open everything, synchronization, everything, the clients, everything. It was what lasted more in our installation. But once we have already in place the firewalls, it is pretty easy to just make any change to infrastructure because we have this automated. And the funny thing is that we are even installing Vault runtime with the help of Vault open source, because Jenkins and Ansible are using Vault open source to just store the secrets they need. When you're installing a product in our architecture, you are using Vault open source, so we are just, in fact, installing Vault runtime with Vault open source. Let me explain a simple use case in BBVA. This is not just the Spain mobile banking application. This is the mobile application of each country I mentioned before. In South America, many countries, in Mexico, Turkey, and in Spain. In this example, we are seeing different layers. The first layer is Akamai, second layer is the front end, and the third layer is the back end, and the five, which is not depicted, maybe would be the mainframe, IBM mainframe. So what we have is Akamai deciding what kind of traffic goes to the cloud or to the data center. For example, suppose that you have 20% of the traffic going to the cloud and 80% going to the data center. And applications are running entirely into the cloud. The front end, back end, also Vault. So again, when Akamai redirects the request to the Vault installation, it goes to the cloud. And just we are avoiding crashing traffic. This is one of the best and few installations that are executing our hybrid architecture perfectly. Because when you're thinking about other solutions, you're having much problems when you're trying to synchronize data. Databases or just buckets. It's not so easy as Vault is implementing this synchronization of data. And these kind of applications are writing and reading secrets constantly, many transactions per second. It's very critical to have everything in place and with zero downtime. So what about the future? The first thing we are going to implement or expand in Vault is the use of HSMs. Why? Because right now, if something happens and somebody restarts the machines, we find the nodes of Vault sealed. We have to unseal Vault manually. So with the help of the HSMs, we are going to unseal Vault automatically. We are installing Cloud HSMs in Amazon and Thales or Encipher HSMs in the on-prem data center so that we integrate with Vault so that we are able to unseal it automatically. And we also using HSMs or just planning to use HSMs for the certification authority. You know that in BBVA, we have many we are issuing certificates for everybody, and we have many products like Microsoft CA or others. But why not? Once you have such kind of installation in BBVA, so very well designed and available, why not start using the certification authority? We didn't use it yet because we didn't have the possibility of just integrating HSMs for the certification authority, which I think is coming in the next release. So we are going to configure up sub-CA so that we have another one and then available through our API to issue certificates automatically. We are already doing it with Vault open source, but this is another possibility that once you have a very big installation, you can integrate everything in just one installation. I could count like 5 different Vault installations for other departments. So we are cryptography, we are deploying globally our infrastructure to everybody. It's no need that every department has their own Vault installation. Another good thing that Vault is implementing is the possibility of just managing keys in the cloud, managing keys with Google, Azure, Amazon Web Services. This is another feature that we are exploring, but what we are missing right now, I know that is against automation, but we are missing a console because sometimes key custodians that are not technical savvy. So they need to right-click, and then we have to educate them. But this is something that is, I don't know if it's coming in the future. We are exploring that possibility. Having the possibility of bringing your own key to the cloud is very important because we are starting to have regulations that require to just create the key in your main data center because of random number generators, and then push the key to the cloud. And the last one, but not least, is the encryption and tokenization feature that Vault has. We already have in cryptography a big installation where we are providing cryptography services. The problem for using this functionality with Vault is that in a bank we have many algorithms required. You have like everything, no? And encryption in Vault right now is implemented with several algorithms. Sometimes it's not enough, but why not? Why not, if we have somebody that is going to use an API and is requesting a very stable installation and available installation, why not start using encryption and tokenization? So that are the 4 scenarios that we are exploring in the future. So I would like to conclude that not only for storing secrets, but for pushing keys to the cloud, or just issuing certificates, or encrypting, Vault is going to be a key component of the architecture in BBVA that is very well aligned with the strategy of cryptography, because if you remember, what we were doing is just to encrypt, issuing certificates, and just providing tools for secrets management. So it's doing more or less what we do. And that is very well aligned with the strategy of BBVA of computing hybridly between the 2 clouds without any effort. So I would say that the relationship between BBVA and HashiCorp is going to last many years and with very great success. This is what I wanted to share. Thank you for coming. If you have any questions, I'm going to respond them in the HashiCorp zone.